Hello everybody. In this video we are going to cover scalars and vectors. Regarding vectors, we're going over just enough so that the physics lessons involving two-dimensional motion makes more sense. This involves how to add, subtract vectors, and multiply them by scalars. Let's begin. A scalar is a physical quantity that has magnitude but no direction. Scalars that we have dealt with previously are distance, time, and speed. For example, time could be expressed as delta t equals 51 seconds, but we would never put a direction with time. A vector is a physical quantity that has both magnitude and direction. Vector quantities we have dealt with include displacement, velocity, and acceleration. For example, velocity equals positive 2.1 meters per second. Besides the positive and negative sign, there are other ways to express direction, such as north, east, forward, up, and right. Also, if the quantity is a vector, it has an arrow punctuation over the variable to indicate it as such. The arrow punctuation over the variable always faces right and does not change based off the direction of the answer. A vector could be drawn visually as well. Take a look at vector A. It is just a large arrow and it is pointing to the right. If we place a negative in front of the vector A, it flips the vector and points it in the opposite direction. What happens if you multiply vectors by scalars? For example, let's take vector A and multiply it by 2. All it does is double the length of the vector. What about adding and subtracting vectors? When you combine vectors through addition or subtraction, the vector you get is called the resultant vector. Let's go over the rules of combining vectors by using vectors A and B located below as an example. For each vector, there is the tail and the arrow point. To combine vectors, connect the arrow point of the first vector to the tail of the second vector. A is the first vector here and B is the last vector. Lastly, draw a vector starting from the tail of the first vector, vector A, straight to the arrow point of the last vector, vector B. This is your resultant vector. You can label the resultant vector as R or A plus B. Let's do one more example using the same vectors A and B. This time it's going to be A minus B. Since vector B has a negative sign, all we have to do is flip the vector in the opposite direction. Then we can still follow the rules by connecting the arrow point of the first vector to the tail of the second vector. Draw a resultant vector from the tail of the first vector straight to the arrow point of the last vector. And that is the answer for this vector operation. Just a reminder, there are a lot more details to vector operations which are also covered in math classes and later physics classes. What I covered in this video is what we need to move on to two-dimension motion. Thanks for watching, and I hope you found it helpful.